We're going to be analyzing roller coasters, and there's a few things that you need to know in order to actually analyze them, and that you may not have heard before. So the first thing is what we call apparent weight. Apparent weight is actually the normal force or the support force acting on you, right? Acting on your body. It's the sensation of your weight. It's not mg, okay? It's the normal force. So in order to solve for it, right, to find it, you need to use Newton's second law. You need a free body diagram and net force equals mass times acceleration. Because if you're sitting in your chair, you're going to have this free body diagram almost always, right? And your net force is going to be normal force minus mg. Not always, but most of the time. If you're on the inside of a loop, you might have a free body diagram that has normal down and mg down. So it'll be Fn plus mg, right? So it depends on the situation, but you must draw a free body diagram, then write out Newton's second law and solve for the normal force. So if you're asked for apparent weight, that's what it is, okay? What's called a force factor is also, you might have heard it as called a g-force, okay? We're going to call it a force factor. It's a ratio of the apparent weight to your actual weight. So what that looks like is the force factor, FF, equals Fn, which is your apparent weight, over your actual weight, Fg, right? So this is your apparent weight, and this one is your actual. Your actual weight shouldn't change from ride to ride, right? It's your mass times gravity. So if it's 60 kilograms or 54.2 or 44.7 or 73.4, whatever your mass is, times 9.8 will give you your actual weight. So how do we distinguish that from the number of g's? This is an acceleration, right? This is actually has to do with acceleration. So 1 g is 9.8 meters per second squared. 2 g's is 2 times 9.8. 3 g's is 3 times 9.8. It's a ratio of your acceleration to 1 g. Okay, so what it looks like is acceleration over 9.8. That's your number of g's. Okay, so these are different things that you're going to have to calculate when we're doing our ride analysis. So let's talk about safety. Ride safety has everything to do with the number of g's, and the number of g's is related to the force factor, but the force factor is more a sensation of weightlessness. So we'll talk about that issue in a second. So in terms of safety, a safe ride at the bottom of a loop, well, actually any time, you have a maximum of 4 to 6 g's, okay, maximum. For short periods of time, most people can withstand 6 g's, but for extended amounts of time, 4 g's is really enough. Otherwise, you black out. Right? Most people can't withstand more than, somewhere in that range. The minimum, we only have a minimum when you're inverted at the top of a loop, because that's where it's dangerous, you can fall out. So the minimum you want to have at the top of the loop is 1 g. If you feel less than 1 g anywhere else, it's not a big deal because it means you're in free fall, but as long as you're not upside down, being in free fall is not a big deal. So these are your limitations for safety. So when they're designing a roller coaster, these are the limitations, okay? on your ride. And this is why we're doing this analysis, to get a sense of, well, where is it safe, or is the ride safe, and why do you feel what you feel? So in terms of the thrill, a thrill comes from acceleration, not just from speed. Okay, you don't actually have to go very fast for it to be thrilling. You just have to be changing direction or changing speed. So either of those two things will cause a thrill. What about these sensations? So let's talk a few more minutes about force factors. So the sensation, right, of weightlessness means you have an apparent weight less than 1. Right? Oops, a force factor, sorry. A force factor of less than 1 will mean you feel weightless. When the force factor is equal to 1, you feel what we call normal, right? You don't feel like you're coming out of your chair. You don't feel like you're sinking into your chair. And a force factor greater than 1 means you feel heavier than normal. Okay, this is lighter than normal. Right? When force factor is less than 1, greater than 1, you feel heavier. You feel pushed into your chair. So that's why we're going to do this, so you can kind of interpret what's going on at different parts of the ride. Keep these terms in mind when you're doing your roller coaster ride analysis.